Okay. So I got a file f1.txt of size 192 MB, number of blocks 192, right? By 64, right? 3 blocks. B1, B2, B3, B1, B2 by 10 lakhs, B3 by 10 lakhs, right? Yes. B1, B2, B3, right? Yes. How these 3 blocks are going to get distributed across multiple slaves, right? I got to assume that I got slaves in this way. I got slaves like this, right? Slave 1, slave 2, and slave 3. Slave 1, 2, and 3, right? Yes. In slave 1, B1 is stored. In slave 2, B2 is stored. In slave 3, B3 is stored, right? Yes. B1, B2, B3. In B1, 10 lakh records. B1, 10 lakh records. B2, 10 lakh records. B3, 10 lakh records, right? So this is the master node we call name node, right? Name node stores the metadata information, data about data, right? It won't stores the data. Actual data is stored by the data node, slave nodes. Metadata is stored by this name node, means, for example, a file divided into blocks B1, B2, and B3. B1 block, B2 block, and B3 block. B1 stored in S1, B2 in S2, B3 in S3. B1 in S1, B2 in S2, and B3 in S3. This how this data is getting stored, how this blocks, how the file divided into blocks, how this blocks getting distributed, stored across multiple slaves. Tomorrow, if you want to retrieve, right, name node, if it wants to retrieve this f1.txt, it should combine the memory location addresses of this B1, B2, B3 stored in S1, S2, S3. Fine. Data processing, how this data processing, right? Yes. To execute, for example, job is to process f1.txt, right, into job divided into tasks. In Hadoop, always the number of tasks. So here file divided into fixed size blocks of 64 MB, or if you give 128, or if you give your own custom size, the blocks will be taking that default block size, going to be distributed across multiple slaves and processed by multiple systems parallelly, right? And the job is divided into tasks. In Hadoop, always the number of tasks depends on number of unique blocks. Number of tasks equal to number of unique blocks means how many blocks here? 3 blocks, right? 3 blocks. 3 blocks. 3 blocks means 3 tasks, right? 3 tasks. 3 tasks. T1, T2, T3. T1, T2, and T3. So job to process f1.txt into how many tasks? T1, T2, and T3. So if you want parallel processing, right, job to be divided into tasks, the tasks need to be assigned to multiple. T1 for executing, right? T1 for executing B1. T2 for executing a B2. T3 for executing B3. B1 10 lakh records. T2 for executing B2 10 lakh records. T3 for executing B3 10 lakh records. Okay. Now try to say who should execute this T1 task? Yes. Who should execute this T1 task? Means B1 block execution. Slave 1 only, right? No other choice. T2 by S2 only. T3 by S3 only, right? So three tasks. T1, T2, T3 are executed parallelly by three slaves, S1, S2, S3 parallelly. So there is no task is in the waiting state. Understood, right? If you take any file, how this file divide into blocks, default block size 64 MB into blocks, you are getting the blocks are getting stored across the slaves B1, B2, B3. Name node stores the metadata information and processing the file. The job is divided into tasks. How many tasks? Number of unique blocks, right? Number of how many unique blocks here? 3 blocks only. All are unique, right? So 3 tasks. T1 task for executing B1, T2 is for executing B2, T3 is for executing B3. So who should execute these tasks? T1 task S1 only, right? See T1 task S1, T1 task will be assigned to slave 1, T2 task to S2, T3 to S3. So here I said if more slaves, right, more speed. If less slaves, less speed. If only one slave, no parallel processing at all. No parallel processing at all, right? Yes. Okay. Understanding, right? Yes. Now, these 3 tasks are executed by the 3 slaves parallelly. Okay, think that if you take a bigger file, more tasks you will get. More tasks are executed by multiple slaves parallelly, as these are machines, right? Slaves are machines. Suddenly, if multiple tasks, if 3 tasks are executed by 3 slaves parallelly, suddenly if any one slave goes down, then two things you can observe, two drawbacks you can observe, right? One is data loss, 10 lakh records lost. Second one is this task T2 got failed. Task T2 failed means job also failed. So data loss, job failure. How Hadoop is going to overcome this kind of situation, right? Means how the data loss and this task failure means there is a concept called replication and fault tolerance, right? Now today my discussion like replication, fault tolerance. Okay. Replication and fault tolerance, right? Yes. Replication and fault tolerance. Replication, like it's like replication, it's like duplication, right? Default number of replications. Default number of replications. Replications we call replicas. 3. By default, 3 replications. Default number of replications or replicas 3. Okay. Default it is 3, but if you want to configure, if you want more replicas or replications, you can increase or decrease the replications. We can configure the replications, right? I'll discuss how to configure, increase or decrease the replications. Means duplication or replication is for the file or for the blocks. Understand here, these replications are for the file or for the blocks. Okay, observe this example to understand this entire replication and fault tolerance mechanism, fault tolerance model in Spark, sorry, in Hadoop and Spark, right? So later I discuss about Spark, but f1.txt, think it has got 192 MB, the block, the size of this file 192 MB. So this file divided into blocks. Any file in Hadoop divided into blocks. Number of blocks. How many blocks? The size, whatever the size, by how many fixed size blocks. The size of each block, it is 64 MB or 128, depending upon that, it will be divided into blocks. Here 3 blocks, 64, 64, 64, exactly 192, right? 3 blocks. 3 blocks means B1, B2, B3. Assume B1 block, B2 block, B3 block. Now replication, right? Replication. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times. Totally 9 blocks. B1 by 3, B2 by 3, B3 by 3, right? 9 blocks. How these 9 blocks are going to get distributed across these slaves, right? Assume these are the slaves, these are the slaves, right? S1, S2, ES3. In S1, how 9 blocks need to be stored? B1 here, B2, B3, B1, B3, B2, B3, B1, B2. So 9 blocks stored across these 3 slaves, right? Yes. This is the name node, stores metadata information. All right. F1.txt, yes, divided into 3 blocks, B1, B2, B3. B1 stored in S1, it is stored in S2, also it is stored in S3, also it is stored. B2 is stored in S1, in S2, and also in S3. B3 also in S1, in S2, and S3. In the previous example, I said if the slave goes down, then 10 lakh reports. If the data is sensitive data like banking data, right? Huge loss, right? Okay. Here B1 is stored across the 3 slaves, B2 is stored across the 3 slaves, B3 also stored across the 3 slaves. Now, data processing. Yes, job to process f1.txt. So job always divides into tasks, number of tasks. How many tasks here? Number of, see why I'm saying every time unique blocks here, Number of unique blocks. Try to answer how many unique blocks here. How many unique blocks here? Three, right? It's three. It's three blocks, not nine. 9 is duplicated, but unique blocks are 3 only. 3 blocks means how many tasks? 3 tasks. T1, T2, and T3. Yes. Okay. Your job to process f1.txt. Yes. Divided into 3 tasks. T1 task, T2 task, T3 task. T1 for executing B1 block, T2 for executing B2, T3 for executing B3. Now, who should execute this T1 task? Now try to answer now. Who should execute this T1 task? S1 only. S2 can't it execute? It has got B1 block right in it. S3 also has got B1 block in it, right? Previous example, B1 block is stored in S1 only, means S1 only should. For example, I want to give a task to 3 students. One student from mathematical background, one is physics background, one is chemistry background. If any mathematical task comes, I need to give to mathematical student only, right? There is no other choice. If any task related to physics, I need to give that student with the physics background, no other choice. But if all the 3 students are got the knowledge on all the 3, I can give to any of one, right? Here also, right? My task T1 can be executed not only by S1, it can be executed by S1, S2, and S3 also, right? Because B1 block is present in S1, S2, S3. In the previous example, without replication or duplication, B1 is stored in S1 only. S1 only need to execute. But here I got S1. Similarly, T2 task can be executed by S1, S2, or S3. Any one should be selected here. All the 3 won't execute. All are S1, S2, S3. Can be executed, I'm saying. But assume the master node has selected S1 only to execute this T1 task. For executing T2 task, the master node has selected S2 only, right? Assume. For executing T3 task, S3 only selected by the master node. Assume. Now try to answer here. T1 task by S1, T2 task by S2, T3 task by S3. 3 tasks are getting executed. 3 tasks are getting executed, right? By the 3 slaves. Suddenly, if any one slave goes down, do you think is there any data loss here? Try to answer. Is there any data loss here? If S2 slave is down, S2 is for executing B2 block. If S2 is down, still the B2 block available in S1, S3, right? S2, if the slave is down, the machine is down, then S2 is for T2 task. T2 is for executing B2. Still that B2 available in S1 and S3, right? In the previous example, if S2 down, then the data in that gone. But here still you got replication, B2 stored in S1 and S3 also. So S1 and S3 can execute those tasks. T2 task can be executed by that, right? Yeah, dynamic replica is, but replication, it depends upon your sensitivity of your data, right? How many replications you want. How many replications you want depends upon the sensitivity. If you want more replications, even you can configure. I'm saying you can increase. Even if one down, not a problem. Still, there is no data loss. Still, the T2 task can be executed by S1 or S3. Here, okay, your problem solved, right? Here, no data loss, no data loss, and no task failure. The task T2 can be executed by any of the other slave. Now, okay. Now, I got a query here. I got a query, right? T1 task can be executed by slave 1, slave 2, and slave 3. Why the priority is given to S1 slave? Why not S2, S3? What is the criteria followed in allocating a task to a slave by the master node? That is one. If a particular slave goes down, then the T2 task to be assigned to which slave? S1 can execute, S3 can execute. To which one? S1 or S3? To which slave I need to provide this? What is the criteria followed in assigning the tasks to the slaves? Observe here. Observe if you want to know that. Slave 1 executing T1 task. Slave 2 executing T2 task. Executing T3 task. Slave 1 executing T1, slave 2 executing T2, slave 3 executing T3 task. Suddenly, slave 2 is down. Then T2 task should be assigned to S1 or S3. What is the criteria followed here? This is one. The same criteria is followed even for the first time when the task assigned to the slaves. To which slave I need to assign that. So here there is 4 steps criteria followed in Hadoop, right? 4 steps criteria. In assigning tasks to the slaves. First one, name node selects the slave which is highly configured, Name node selects the slave which is highly configured, means which has got high configuration, system configuration, which is highly configured. Think that if both have got the same configuration, if both of them has got the same configuration, if both the slaves if both the slave s1 as are equally configured, right? Then in such case, both has got the same configuration, both have got high configured, both are like that. Then name node select name node or master node, right? Name node selects the slave which is more ideal, which is more free, which is more ideal. That is free, right? Okay. Name node selects the slave which is more ideal among the, which is more ideal. For example, slave 1 executing 4 tasks, slave 3 executing only 1 task. So we we cannot burden slave 1 by assigning one more task. We can assign the task to slave 3. So think that if both the slaves are free, if both the slaves are free, then name node selects if both are free, name node selects the slave which is nearest to it. Okay. See, master node in one state, slaves in different states. Otherwise, master node in one city and the slaves in different cities are all in the same city or all within the same lab, right? Which is nearest to it, which is nearest. Think if they are within the same distance, right? If they are within the same lab, masters and slaves, then name node selects the slave which is nearest to it. But if both the slaves are equally near, assume if both the slaves are equally near, if both the slaves are equally near, right? Yes. Then finally, name node selects the slave. Name node selects the slave. Name node selects the slave, right? Yes. Name node selects the slave which has good health status. If both have got same configuration, doesn't mean that both have the same good health status, right? Yes. Okay. it has good health status means I think that now and then a particular slave going down, right? But if both has got both the slaves, if both the slaves have got good health status, then finally name node selects any one node, right? Randomly, but it won't go up to that extent, right? But in the first or secondly, which is more ideal or which is highly configured or which is nearest to it, right? Depends, right? Okay. Now, means here, observe this. What do you mean? Replication, you understood. Fault tolerance means when multiple tasks are executed by multiple slaves, then suddenly if any one slave goes down, then the task of that slave is assigned to any of the other available slaves. This process we call it as fault tolerance mechanism, right? So the default number of replications are 3. If you want to increase or decrease, we can increase or decrease the replications, right? So here two things I'll be discussing here. So configuring block size and replication. Configuring block size and replication, right? Yes. How to configure the block size and replication is go to Hadoop install directory. There you can see Hadoop /etc/conf within the conf folder, right? hdfs-site.xml file. hdfs-site.xml file. Open this file. And configure. So here in XML file means we can create our own tags, user defined tags, right? Yes. Configuration, right? We need to close the config, this opening and closing. Closing means in this way it is /configuration and this open and close. Within this configuration, we have got one more tag, property, right? Property open and close. Within this property tag, name of the tag, okay, name dfs dot block dot size, dfs dot block dot size. Close that name, property name, property value next. Default block size. For example, I'm keeping for example 50 M or 100 M, whatever you want, like MB. How much you want to keep, that you can specify here, right? Yes. Value /value. One more property I need to set, right? One more property. dfs.blocks.size. Here next, one more property. I'm copying the same thing, right? Yes, pasting here. dfs.block.replication here. Replication. How much? How many? By default, 3, right? I want to keep 4 or 5. Okay. So this file we need to, this will be an empty file, hdfs-soy.xml. This thing we need to keep within that file. Properties, two properties. One is block size, how much you want, 200 MB, 50 MB, and block size replication. See, keeping block size, see, if I want to keep a bigger block size, default block size, which is advantageous, keeping block size a bigger block size or keeping a very small block size? Which one is advantageous? Having a bigger block size, default block size, or a smaller block size? For example, if we are keeping the default, yes, try to answer. Bigger block size. Okay, assume I got a file. 1000 MB. The file size is 1000 MB. I'm keeping default block size. I'm keeping the default block size as 500 MB. I'm keeping. I'm just configuring as 500 MB. Means your file is divided into how many blocks? B1, B2. B1 500 MB, B2 500 MB. S1, S2. Means here, what is the drawback here? Can you see what is the drawback here? For example, I'll give a labor example to understand this. Your building constructional work, you brought 10 laborers. You brought some 10 laborers for work. You divided the task to only two tasks only, and you are given to only 2 slaves, S1, S2. Remaining 8 slaves are ideal. Remaining 8 slaves, if I give the task to all the 10, I can complete the task. More speed I can achieve, right? More speed I can get, right? So here B1 in S1, B2 in S2, only 2 slaves are working. I think that you have got some 10 or 20 slaves available. Out of 20, only 2 are working. But if you had got less block size, think that if I got block size 100 MB, then into 10 blocks, 10 slaves doing the work and 2 slaves doing the work. See the speed. If I keep 50 MB as the block size, 20 blocks, 20 slaves getting more work, right? So always the number of slaves, the number of slaves required, how many slaves need to be configured, means we say commissioning and decommissioning, adding and removing of. It depends upon your project data volume, right? Data volume, how many slaves need to be configured. But here, if you have got to think that a 40 node cluster, 40 slaves, 40 slaves are there, but you are giving work to only 2 slaves. If I give to all them, then I can achieve more speed, right? That's one. And if I give, for example, if I give that block size, okay, file 1000 MB, block size 5 MB, if I give, is it advantageous? Then into how many many blocks, many slaves, is it advantageous if I give 5 MB or 10 MB? Then I'll get more blocks, I'll be getting distributed across multiple slaves. It doesn't mean that in a slave only one block to be stored. Within a slave, we can store 1 block, 10 blocks, 50 blocks, 100 blocks also. Means if I got only one slave, means all the blocks storing in one slave only, right? Means here block size is 5 MB. Is it advantageous or disadvantageous? Try to answer. Disadvantage, right? Here also, this 5 MB is to think that it is stored across 20 or 30 slaves. For a small file, You are dividing into multiple blocks, storing across multiple slaves. Again, I'm retrieving them from the slaves. So it's time taking process, right? It's anyhow, it's a small file. Then instead of storing in across multiple slaves, why can't you store in 3 or 4, right? So that's the reason we are that Hadoop is giving some default block size as 128 MB, 64 or 128, right? Yes, but if you want, we can configure. Just now I said how to configure, right? Keeping our own block size. Understood, right, everyone? Here, this is so everything is. I said we'll be spending more time on this Hadoop and Spark, right? Everything will be clearly discussed. So if I want the sessions to be more interactive, right? I'm getting okay. I want you people to respond more. So any queries you have got as part of today's session, right? As said by the online team. So they have given a messages in that chat box, right? If you can see, the link will be changing from tomorrow. Only those who got enrolled, who got registered, will be getting the link to your mail IDs. Okay, a WhatsApp group will be created from those who got registered for the direct interaction, right, with me. If you got in the future, if you got any errors or anything, right, you can just take a snap of it and you can keep in the WhatsApp group. So we'll be discussing examples, right? Monday to Friday your classes, but if you're running out of time, I will take Saturdays, right? Later. If anyway you want to go like Hadoop and Spark parallel also, you can go parallelly, right? Yes. Clear notes will be provided. Everything I will be typing and showing you with the clear diagrams. Yes. And whatever practicals I do, right, everything I'll be storing in a notepad or a word, and I'll be just forwarding you. If you got stuck anywhere, you can just check and you can execute, right? Yes. Okay. Any queries you got? So you can see the chart panel, right? The payment details, process, procedure. Timing of the regular class, right? Regular class timing 7 p.m. to 8 p.m., right? 7 p.m. to 8 p.m. So if you're done with anyone, if you're done with the payment, you are supposed to share the screenshot to online team. DurgaSoft online training at the rate gmail.com. You can see in the chart panel, right? You can copy or you can take the snap of it. Yes, any queries you got? Right. So tomorrow, just I'll be discussing some more examples on this replication, fault tolerance. Monday to Friday, and Saturday sometimes I'll be taking some bigger sessions whenever I'm free. I'll be pre-intimating you about this. Spark in brief, in depth, I'll be discussing with SCALA programming, right? So if you talk like for Spark, it takes 1.5 months. For Hadoop, it takes 1 month. Totally 2.5 months, right? So okay, if I'm done with the queries, if there are no other queries, I'll just sign off for now. Meet you tomorrow, right? Same time at 7 o'clock. But tomorrow the link will be changed. Check it, right? Yes. Fine. Any more queries? Okay. So thank you all for your time. Thank you. Yes.